So guys, you can see that there behind you can see the PIC, that is our PIC. This is the TTP229 keypad module, capacitive touch keypad module. This is LM016 LCD. Now see, LCD is showing waiting. Let me press a key. I press key 1. It shows key 1 pressed. If I press key 2, it shows key 2 pressed. If I press key 3, it shows key 3 pressed. Key 4, it shows key 4 pressed. And I press key 8, it shows key 8 pressed. If I keep a key pressed like key 6, it shows key 6 pressed for as long as I hold it. Then I leave it, it remains there for 1 second and then fades away. So let me show you the hardware. So this is our simple hardware over here. You can see we just use a TTP229 module and the LM016 LCD to display the output. Now for the 8 key mode, we do not need these 2 pins, SCL and SDO. In case of a 16-bit mode, we only need these 4 pins because this is an I2C interface. So for the 8 key mode, you just connect this directly with any GPIO pin. I am using port B for this, and for the LCD, we are using some other pins. Now, if I go to the programming, you will see that the code is very simple, looks lengthy, but in reality, it's a simple code. You go up, we just initialize our LCD with our desired pinout, and this key command initializes the LCD. Then we declare the pin directions. That is, all the pins are to be taken as input of the port B. Then we give the initial state. By default, it's 0. If key is pressed, it becomes 1. Then we give some initialization delay. Here we go for our forever loop. First, we check the first button. If port P.F0, that's the first key is pressed. Then we gave some debouncing delay and we checked again. If the key is pressed, it displays key 1 pressed. The text is displayed for 1 second. After that, it clears the LCD. And then we check again. If similarly, if B.F1 receives a 1, pin B.F1, it means key 2 is pressed. If B.F2 receives a 1, it means key 3 is pressed. And similarly, we go down. If B.F5 is pressed, it means key 6 is pressed. And if B.F7 is pressed, it means that the key 8 is pressed. And it remains displayed for 1 second. After that, the screen is clear. Else, if no key is pressed, it keeps on displaying waiting. Now, this programming is giving us this result over here. See, it's waiting. And as soon as a key is pressed, it displays a key press. Guys, welcome to learning microcontrollers. In this video, I will show you how we can use a TTP229 touchpad. It's basically a capacitive touchpad module with a PIC16F877A, and it works on 2 modes. One is a 16 key mode and one is a 8 key mode. We will be using the 8 key mode in this video. So in the next video, I will show you how to use a 16 key mode as well. So guys, this is the touch keypad I'm talking about. You can see that TTP229 is easily available in the market and it's a capacitive type. This means that you do not have to touch the buttons actually. You just bring the finger near and it automatically gets pressed. You can see it has 16 keys. It operates on 2 modes. You can see over here we have VCC, ground, SCL and SDO. This means that this is the I2C port. If you use this port, then you can use all the 16 keys. But in case you don't want to use this protocol, you want to use these pins out 1 to out 8, then this is just a direct digital output interface. So this will directly go to your GPIO pin, and by default it is 0, and if the key is pressed, it becomes 1. So this is simple 8 key mode, these 8 pins. So we will be using the 8 key mode in this lecture. In the next lecture, we will be using the I2C for 16 key modes. So let's get started. So first of all, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. And this over here is our 16x2 LCD. I will be using this to display to you which key is pressed. So we will be using an LM016 16x2 LCD for the output purpose. Now to connect this LCD with the PIC, we will need a 3-pin potentiometer. This is our 3-pin 10K potentiometer. So you can see that it has 3 pins, 1, 2 and 3 mentioned on the body as well. The one I have, it's a Boheng or Bonds type. So you can use other ports as well, but remember these blue ones are way more accurate. So I suggest you use these. So for the LCD, you can see that it's mentioned on the body as well. It is 16 pin port, 1 to 16 from left to right if you hold it like this. Now guys, let's do the wiring. You common pin number 1 and 5 of the LCD like this, and you connect it to the pin number 1 of the potentiometer. From there, you send it to the ground of your PIC like this. Now for the pin number 2 of your LCD, that is the VDD pin, connected to the pin number 3 of the potentiometer like this. From there, you send it to the VCC pin of your PIC like this. Now whatever the source is powering up the PIC, giving 5 volt to the PIC, will also give 5 volt to the potentiometer and then to the LCD as well. So guys, the next pin, that is pin number 3 of the LCD, is the VSS pin. This is the contrast adjustment pin. I will connect it to the adjustable pin of my potentiometer, that is pin number 2, like this. Now guys, pin number 4 of your LCD is the RS pin, and for this you can connect it to any available GPIO pin of your PIC. I will connect it to the port D, pin number D1, that is pin number 20 of the PIC. For the pin number 6, that is the enable pin, I connect it to the pin number D0 of the PIC. Leave pin number 7, 8, 9 and 10, directly go for the pin 11. Pin number 11 is the data pin 4 of the LCD, connected to any available GPIO pin. I'm going to use the port D, pin 4. For pin number 12, that is data pin 5 of the LCD, I use D5 of the PIC. For pin number 13, that is data pin 6 of the LCD, I will use port D, pin 6. For pin number 14 of the LCD, that is data pin 7 of the LCD, I will use port D, pin 7. Now guys, these 4 pins 7, 8, 9 and 10, they are from data pin 0 to data pin 3 of the LCD. These pins are required if you use this LCD in the 8-bit mode, while we are using this LCD in the 4-bit mode, and for our application 4-bit mode is enough. So leave these pins floating, no need to connect them. Now pin number 15 and 16 are for the LCD backlight. Connect pin number 15 to positive 5 volt, 16 to ground. In this way your LCD will also have the backlight on. So our LCD is connected. Let's connect the keypad TTP229. So this is our TTP229. You can see the pins are labeled, but I will label them again. This is VCC, then ground, then we are not going to use SCL and STO because in this tutorial we are only going for the 8 key mode, while these two are required for the 16 key mode. So for the out keys, we have 8 out keys, out key 1, 2, 3, 4, 5, 6, 7, 8. Now out key 1 correspond to button 1. Whenever the button 1 is pressed, O1 will become high. If button 2 is pressed, O2 will become high. Button 3 is pressed, then O3 will become high. So in this way, we only need GPIO pins to interface this with our PIC. So you can use any GPIO pins. So there are total 8 pins, while port B also have 8 pins. So I will use the port B of the PIC. So connect your first of all VCC to the VCC of the PIC. It operates at 5 volt, ground to the ground like this. Now for the O1 pin, I will use pin B0 of the PIC, port B, pin 0. For O2, output 2, I use B1, output 3, B2, output 4, B3, output 5, B4, output 6, B5, output 7, B6 and output 8, B7. So in this way, all 8 pins are connected to the 8 pins of the port B. So complete port B is utilized for the touchpad. So we will have access to 1, 2, 3, 4, 5, 6, 7, 8 keys only. These 8 keys will not be available in this tutorial. So this is our simple hardware connection. So let me introduce you to the hardware, then we move on to the programming. So guys, this over here is the hardware. This is the keypad over here. This is the LCD. Behind you can see the PIC, and behind you can see the PIC3 connected as well. Rest is just a trainer board, so no need to worry about it. So now let's get to our micro C to start the programming. So guys, this is our micro C for PIC. Let me zoom in. You can see that this is version 7.2.0. I also have a lecture on this, how to download and install this for free from our official website. You can just check that video in the tutorials. So click on File, New Project. This window pops up, New Project Visit. Click on Next, write the name of the project. The name of the project I will write is TTP229 interface PIC16F877A with LM016 LCD. Any name. Select the path where your file will be created. Select the microcontroller you are using. I am using PIC16F877A. Select the crystal that you have connected to the pin number 13 and 14 of your PIC16F877A. I have a 16 MHz crystal. So click on Next and Finish. So guys, this window pops up. I press Ctrl S to save my work before I do anything else like this. Now guys, first of all, we will need to initialize the LCD because we are using the LCD. So to initialize the LCD, go to the right. There you have the micro E libraries expanded. You have the system libraries expanded. Go down, you have this LCD. Check mark this library, expanded. Go there. Inside it, you have this command called LCD-init. Double click on this. This window pops up. And in the example here, you have these commands. You copy them, copy them, copy them, copy them. I went way too low till here. Okay, till here you copy them. Now go back, paste it above the void main in the one-time loop. Oh, sorry, above the one-time loop. So there you have this command. Now first of all, see, this is the LCD pinout setting, and we are starting from data pin 4, 5, 6 and 7. Only 4 pins are being required because we are using this LCD in the 4-bit mode. If you want to use it in the 8-bit mode, you just copy these 4 again, and you also add D0, D1, D2 and D3. So it will become 8-bit. Now for the pinout setting, it depends upon us. Like I have selected for the LCD RS pin, I'm using pin number D1 of my PIC. For LCD EN, I'm using D0. For LCD data pin 7, we are using port D pin 7. For LCD data pin 6, we are using port D pin 6. For LCD data pin 5, we are using port D pin 5. For LCD data pin 4, we are using port D pin 4, like this. Now here we have the pinout setting done. Now we do for the pin direction. For the pin direction, do exactly the same you did over here. For the RS, it's D1. For EN, it's D0. For data pin 7, it's D7. For data pin 6, it's D6. For data pin 5, it's D5. For data pin 4, it's D4. Okay, now again go to the right in the same library, LCD INIT, double click on this. Here, go down, there you have this LCD INIT command. Just copy this command, go back, paste it in the one-time loop over here. Now this command will initialize the LCD with this pinout settings. Now I give some initialization delay, not necessary, but I always suggest you give it in the one-time loop. 200 milliseconds is enough. So we have our LCD initialized. Now we need to initialize the port B because our TTP229 capacitive touch module is connected to the port D. Okay, let me close the Steam. Okay, so because we have the TTP229 capacitive touch module connected to our port B, so we need to initialize that. Now there is a command called trace. This is used to initialize the ports or pin directions. Trace B, instead of going pin by pin, we go directly. Port B is equal to 0B, we go in binary. We have 8 pins, so 1 2 3 4 5 6 7 8. Remember I told you in my earlier lectures as well, trace, it's like trace B dot F0 equals to 1. This means that port B dot pin number 0, port B pin B0 is declared as input because it's 1. If I make it 0, it means it has been declared as output. Now it can accommodate LEDs or other output devices. So in our case, since we are using it as input, we are getting input from the TTP229 module. Like we have connected 8 buttons to that port, so we initialize all 8 pins as input. Now it starts from the right. We are using little endian here, so it starts from the right. This is our B0, B1, B2, B3, B4, B5, B6, B7. So total of 8 pins corresponding to our 8 keys. So initial state port B equals to 0 cross 0 0. Okay, we give it in binary 1 2 3 4 5 6 7 8. So all 8 pins have been given 0 status as default because I have checked it myself. By default the button is at 0. By default key status is 0. So by default, if it is 0, then we have to maintain that status. Only this status is supposed to change whenever the key is pressed. If key is pressed, it sends 1. Okay, that's why we will need 1. Now give some initialization delay. Here we initialize the complete port for our TTP229 module. Now we go for our forever loop. While 1 forever loop starts here, forever loop ends here. Inside it, first of all, we check if this key is pressed. So we write here if port B dot F0 double equals to 0. Oh, sorry, 1. If it is pressed, then what it should do? Then it should check again because there can be an accident. Delay MS 50. If it is pressed and it is now being 50 millisecond, wait. If the key is pressed, you wait and check again. If the key is again pressed, check again. If the key is still pressed, okay, if your key is pressed, B dot F0 is pressed, wait for 50 milliseconds. If it is still pressed, then consider it pressed. Close both the brackets. So this is called debouncing delay. This is for the safety. Like if accidentally due to some air particle or some natural phenomena like electrostatic shock, etc., this key is pressed, it will not be considered pressed. Debouncing delay ideal is like minimum of 8 milliseconds. Above 8 milliseconds is good. So inside it, if the key is pressed, we go to the LCD library. We have this command called LCD out. We will display this on the LCD that which key is pressed. Now pin B dot F0 correspond to pin key 1 as I told you in the presentation. So it will show key 1 pressed. It will show key 1 pressed. start writing LCD out. This command writes on the LCD out, then start writing from the first row, first column, keep 1 pressed. Okay, it will show this, and it will keep on displaying this for like delay ms for 1 second. For 1 second, it will keep on displaying this text. After that, it will clear the screen. So to clear the screen, we go to the right. Okay, we will use the else loop. In the else loop, it will be automatically cleared. Okay, here we go. Okay, this is our first loop. Okay, now if the next key is pressed, copy all this, do this for every key. Okay, else if, you can also use a loop as well. Else if port B.F1 is pressed, again check if B.F1 is pressed, then write key 2 is pressed. Now again copy this. Else if B.F2 is pressed, then this means key P3 is pressed. Show on the LCD that key 3 is pressed. Again copy it, paste it. Okay, if B.F3 is pressed, this means that key 4 is pressed. Display on the LCD that the key 4 is pressed. Now again, if B.F5 is pressed, okay, F4, sorry, B.F4 is pressed, then it means that key 5 is pressed. Again copy it. Now if B.F5 is pressed, then it means that key 6 is pressed. Again copy this. Now if B.F6 is pressed, this means that key 7 is pressed. Now next is our last, key 8. Again copy paste this. If B.F7 is pressed, it means that key 8 is pressed. Now instead of writing LCD clear here, I just give it else. Else, if none of the key is pressed, in any other condition, just clear the screen. Go to the right, LCD out. Okay, you can clear the screen, you can write any text as well, so it's up to us. So we make it look more beautiful. So we write here like something waiting. Okay, waiting. It will keep displaying waiting on the LCD in case no key is pressed. So go to the right, we have this command called LCD CMD. We will clear the screen in the loops. Okay, double click, I think it didn't open. Double click on this. Okay, now in this LCD CMD command, you have this command in the example here, clear LCD, LCD CMD, LCD clear. You copy this command, paste it after these delays in every loop. So as soon as it displays this text for 1 second, it will clear the screen itself. And instead of, firstly I thought I will give this over here, but to look at more good, we will keep on displaying waiting if no key is pressed, instead of showing the clear screen. So that will be better. So we clear the screen over here. After displaying the text, it will automatically clear the screen for the next text to be displayed in the next key is pressed. Okay, here you go. Here you go. Here you go. Here you go. Okay, we counter check. B.F0 is pressed. Wait, B.F0, B.F1, B.F1, B.F2, B.F2, B.F3, B.F3, key 4, B.F4, F4, key 5, B.F5, F5, key 6, B.F6, F6, key 7, B.F7, F7, key 8. So here we go, we have our code written. Now we build this code to see if there is any error. Okay, shows no errors, that's perfect. It's built. Now we open the PIC3 programmer tool to burn it into our microcontroller. So this is our PIC3 programmer tools. Let me connect the PIC3. This is disconnected. Okay guys, I have connected the PIC3. You can see that it says PIC3 found. Okay, now let's select the microcontroller. PIC16F877A is the one we are using. this one. If you don't have this tool, you can just go through my video in which I have told you how to download and install this programmer tool in the introductory section. It is free and easy to use. Click on file, click on import hex file. This is the file we just created. Double click on it, click on write. Okay, wait for the file to be wrote. Okay, it is writing the file. Erasing device. Okay, remember one more thing, that see over here I have disconnected the VCC and ground pins. You can see that they have been disconnected. Why? Because here you can see that these two pins, pin number B7 and B6, if you go through my video in which I have shown you how to set up the PIC16F877A, that is the introductory section lecture, you can see that these two pin PGD and PG are required for programming as well. By the PIC3 uses these two pins. If you do not disconnect the module during the programming, there is a chance that it will not be able to program at all, because these two pins are required by the PIC3 as well. So you just connect the VCC, disconnect the VCC and ground pins until the programming is done, then reconnect them. Or you may use a button in case you are using an actual hardware. So that's simple. Or else you do not use these two pins. You use some other pins. That's up to you. Okay, I think the programming is done. Okay, the programming is done. We power up the circuit using this PIC3 programmer tool. I click on. Okay, let me reconnect the module as well. Okay, I connect the ground and power wires. That is the ground wire. This is the power wire. Here you go, it's connected. Okay, it is showing waiting. That's perfect. It should show waiting. As per our programming, it will show waiting if no key is pressed. Okay, let's press a key. I press 1. Okay, it shows key 1 pressed. That's perfect. I press 2. It shows key 2 pressed and then goes away after 1 second. I press 3. It shows key 3 pressed and then goes away after 1 second. Key 4 pressed and goes away after 1 second. Then key 5 pressed and then goes away after 1 second. Key 6, I keep it pressed, it remains pressed. See, it remains pressed for as long as it is pressed. As soon as I release it, it shows waiting. Pick 7, key 7, key 8. See, all the keys are working as per our programming. Now, if I press any of these keys, like key 15, 14, 12, it gives no effect. Why? Because they are not connected, and they will be connected using these two pins which are not connected right now, SDL and SCO, SDO and SCL. They require I2C interface, and I will show you in my future lecture how to use them. So right now we have only gone with the 8 key mode. This is pin 1, key 1, P2, key 3, key 4, and whichever key you may press. So this was it, guys. This is a simple lecture on how to interface a TTP229 capacitive touch module with a PIC. So if you guys have any question, you may ask. We'll see you in the next lecture. So goodbye until then.